Hello friends, here the slotted Aloha. In previous lecture we have covered pure Aloha. In pure Aloha we have seen that when the node have packet to send, then it will send without knowing the channel is free or not. The same thing happens in slotted Aloha also, but in slotted Aloha, or we see that why the slotted Aloha protocol comes to improve the efficiency of the pure Aloha. We see that the efficiency of pure Aloha is 18.35%. 39% is the efficiency of pure Aloha. To improve the efficiency of the pure Aloha, slotted Aloha comes. Here in slotted Aloha, the time is divided into equal slots. Here the time is divided into equal slots because the frame size is equal. Here the frame size is equal. Must remember, here frame size is equals. So the time is divided into equal slots. And slot time, what is the time slot? The slot time is one from transmission time. Here the time is divided into multiple slots. Each slot size is T of x. T of x means transmission delay of the packet. Okay. Here the nodes are synchronized. Here all nodes are synchronized with each others. Okay. So when the node has a packet to transmit, it will transmit only at the beginning of slot. Okay. Here we see there is a multiple slots. Here the multiple time slots. Each time slots, each packet have to send his or her packet. His packet. Okay, his packet. Here the node 1, node 2, node 3, node 4 time slot. Here if the node 1 want to send the packet into the channel, it must have to start its transmission of the packet at beginning of the slot. Is clear? Here the time slots of 4 nodes. Time slots of the 4 node, 1 node, 2 node, 3 node, 4 node. If the node 1 or any node want to send the packets into the channel, it must be start transmission of the packet at the beginning of its slot. Means if you want to transmit the packet into the channel, it must have to start transmission of the packet at the beginning of this slot. Otherwise, the collision will happen. Okay. Here the vulnerable time at which time duration in which no transmission done to avoid the collision. To avoid the collision, transmission must be started at the beginning of time slot. Okay. At the transmission at the duration time, no transmission should be done to avoid the collision. Okay. If at the beginning of time slot, if the packet transmitted by the node, then the chance of collision is minimum. Okay. Here the vulnerable time is frame transmission time, which is T of x. So if one node in transmitting the channel, which time taken by transmitting channel is T of x. So no other channel have to transmit their packet into channel at this duration of time, is T of x. When any node is transmitting its packet into the channel in a T of x time, then there must be no another nodes have to transmit its packet into the channel until one nodes have to complete his packet transmission. Okay. Here, according to Poisson's distribution theorem, P is here the formula of P. When putting the value of P in the formula, we get this. P is the probability, S is the throughput. As we see in previous lecture, P is the probability and S is a throughput. Now, here throughput, the maximum throughput can be achieved. Here, after applying the derivation, after applying the differentiation, we get the maximum value of G. So, the maximum value of G is 1. The maximum value of G is 1, so that throughput will be maximum. For maximum throughput, the value of G must be G is equal to 1, and at G is equal to 1, the maximum throughput value is 1 by 9. This is a constant. Its value is 0.3678. In percentage, it is 36%. Here we see that in pure Aloha, efficiency is increased 36.78. In pure Aloha, it is 18.39. Okay, so here the throughput increased by 100%. Means here 1 by E, the maximum throughput is 1 by E. In pure Aloha, maximum throughput is 1 by 2E. तो इंक्रीज कितने का आया? 100% का इंक्रीज आया. Means from 18.39 to 36.78. So the efficiency of throughput is the efficiency of slotted Aloha is more, which is double of efficiency of pure Aloha. Okay, here the efficiency graph, here from 0 to pure Aloha 0.18 and 0.3678, which is slotted Aloha, which is here the throughput, and here the G. The throughput is maximum at slotted Aloha and value 1. The throughput of pure Aloha is 0.1839 or maximum at 0.5 value of G. So here slotted Aloha efficiency. Now here slotted Aloha efficiency. Let's suppose there is a n nodes in the channel. Here there is a n nodes. Here the channel, and there is n number of nodes connected in this channel. So channel, each nodes transmit in slot with probability P. Here means that if each node has the probability of P to send the node packet into the, means that here each node transmit or send its packet into the channel with probability P. Again, each channel transmit its packet into the channel with probability P. These are two cases. Let's assume. Okay, we have assumed n number of nodes. Each nodes have transmit the packet into the channel with probability P. So here the probability that given node has success in given slot. So we will the probability of success. So the probability of success that packet will not collide and received by the receiver successfully. This is a formula. How we get this formula? I don't go with the derivation of the formula. You must remember the formula only. Okay, so again here probability of the packet. So the probability of the packet to be, so the success probability of the success probability of the packet in a given time slot. Okay, first remember probability of the packet in a given time slot. Success probability of the packet in a given time slot. Here the probability of in case of single node, the probability of the success of the any node frames in given slot time. Here again, here the formula for the probability of the success rate of the frames. Here success of the frames in a given slot time by the all nodes. Here in case of single nodes, here by any node. Here at a specific node, किसी specific node के फ्रेम को टाइम स्लॉट पे सक्सेस होने की प्रोबेबिलिटी. दिस फॉर्मूला. हियर द सक्सेस प्रोबेबिलिटी ऑफ एनी नोड, किसी भी नोड की. हियर द प्रोबेबिलिटी ऑफ सक्सेस ऑफ एनी नोड इन अ गिवन स्लॉट, किसी भी नोड की. सो एन पी 1/c, दिस इज द फॉर्मूला. And here the throughput of the channel. We have seen the formula for throughput of each nodes. Now here the throughput of channel. Throughput of channel means here the throughput of channel is same as the probability of any node. So the success probability of the frames by any nodes in a channel is also called throughput of the channel. Means the efficiency of the channel. So that in channel there is n slots, and the probability of each channel has the probability of success of the frame. So the probability of the all nodes is combined to become a throughput of the channel. Okay, here again the efficiency. Here the derivation of the formula. Where the P is a probability throughput of the channel should be. If the probability of the P and the throughput of the channel should be. If the probability क्या है? P है. Channel की probability क्या है? P है. Then बताना है क्या? Throughput of the channel at P is equal to 1/n. So the efficiency of the channel is, here the formula for efficiency of the channel की efficiency, maximum efficiency can be achieved at 1/n. When the maximum efficiency can be achieved at the value of P is equal to 1/n, and what is the maximum efficiency? Is 1/e. 1/e is the maximum efficiency of the channel. Maximum efficiency of the channel. This is the maximum efficiency of the channel. Now exponential back-off algorithm. Exponential back-off algorithm says that, what is the exponential back-off algorithm? Let's assume there is a two nodes. If there is a node want to send the packets into the channel, when node send packets into the channel, it will collide. So after its first collide, it will send packets again. But what time? The time is random. There is a random time after first. So here, binary exponential back-off algorithm give the random time, provide the value of random times at which the transmitter send the nodes again into the channel. Okay, means that if there is a node want to send the packet into the channel and send the packet, if the packets collide, then again it retransmit. But after what time it will retransmit the channel? So this random time is given by exponential back of algorithm. So if there is a kth collision, it means after first collision, after second collision, after third collision. So here the kth is a number of with collision. With a what's number of collision? Okay, so if there is a first, so it's dependent on 1, 2, 3, 4. This number of attempt. So the kth of collision is number of attempt. Which number of attempts is this? Okay? If the k value is less than 15, if k value is less than 15, then use the number of transmission, choose a number randomly. Then it choose if there is a collision, but number of collision is less than k. If there is a kth number of collision, okay, if there is a kth number of collision, then it will choose time randomly choose the time to transfer the retransmit the frame. So I random time r lies on between 0 to 2 to power k minus 1 to the power k minus 1 means that if it is a first collision, then it will choose the value of r is 0 or 1. If it's a second collision, second attempt, then it will choose the time from 0, 1, 2 to 3. Means after 0 second, after frames collide, get the information, yes, the packet is collide. Now it transfer at 0 wait time. One wait time after one transmit for one transmission time and then send the packet. 2 means after getting the information that packet is collide, then after 2 transmission time, it will send the retransmit the packet again. So this is how it's work. And what is the wait time? Wait time is r into t of x. In case of sorted Aloha, it's t of x, and in case of pure Aloha, it is tp. Okay, and both for pure Aloha can use both. As you know, if it's a third number of collision, if it is a third collision, means if the node send packet into the channel, it collide, then it's first attempt. After this, it will choose the random time from 0 time or 1. 0 time is after collision information, immediately it send retransmit next frame. After immediately it retransmit the frame, and second is 1 means after one transmission time it send the retransmit the channel, transmit packet into channel. But in after first attempt it goes with second attempt. If the first attempt fails, then it goes with second attempt. Second attempts fail. If first attempt goes fail, then it choose second attempt. And but after what time it attempt the second time at 0 time immediately after second collision, and after 1 transmission time, after 2 transmission, after 3 transmission time. If again it's collide, then it's third attempt. It try third attempt. In third attempt, it will choose the time from 0 to 7 transmission time. In fourth, 0 to 15 as go along. Okay, thank you.